Considering this reaction equation involving a complex compound. Roman 1. Name two ligands in the component on the right side. This is our right side. We are supposed to name two complexes, two ligands. We are supposed to name two ligands to the right of the equation. This is one of the ligands. This is the second one. So, two ligands. To the right of the equation. The first one is aqua. The second one is hydroxyl. Roman 2. Before Roman 2, in Roman 1, the question says, name two ligands in the complex component on the right side of the question and explain how they act as ligands. How do aqua act as ligand? Aqua acts as a ligand by donating a lone pair of electrons from the oxygen atom in the molecule to the empty orbitals present in the ion as a central atom. In the same way, this one, hydroxyl, acts as a ligand by donating two lone pairs of electrons present in the oxygen atom to the empty orbital which are present in the central atom ion. Roman 2. Draw a diagram. Draw a diagram showing shape of the complex ion on the right side of the equation and name its shape. So to the right of our equation, we are having this complex. So we are supposed to write the shape. The coordination number in this complex is 6. So iron as a central atom So this is the shape of our complex. So you can just like this. This will be the shape of the resulting complex, and its name is called an octahedral shape. Octahedral. Whenever the coordination number is 6, the resulting complex possesses an octahedral shape. That is really our complex. Draw a diagram showing the shape of the complex ion on the right side of the equation and name its shape. This is the diagram of the complex. Its shape is octahedral. Five, D, 3. Explain why it is difficult to remove a proton from this one. So we are given these two complexes. And then information given by the question is that it is difficult to remove a proton from this one. This one, difficult to remove the proton. It is difficult to remove a proton from this one than from this one. What is the reason behind? Keep in mind, when you are removing a proton, it means you are removing it from water molecules. It's a water molecule. You can remove this, the water molecule, this water molecule, then you remove it from this one. or if it is this ligand here, then you are removing it from this. Then it is difficult to remove a proton. Explain why it is difficult a proton from this. Than from this. This one has got a 3 positive charge, which means that there will be a tendency of electron migration from the periphery of a molecule, the tendency of attracting molecules towards the centrometal atom. The higher the charge on the central metal atom, the stronger will be the tendency of pulling these electrons towards that central metal atom. By doing so, you weaken this bond. This bond is weakened if the tendency of attracting electrons towards the central metal atom is big enough. So, and the greater the factor which determines the amount of this pool of electrons towards the central metal atom is the charge. Obviously, this one will be pulling electrons more towards the central metal atom, leaving this one, leaving this bond to be weak. But this have only 2 positive charge. The pull of electrons towards the central metal atom is less. Therefore, the hydrogen, the bond binding hydrogen is less weak, hence difficult to remove a proton from this complex than from this complex. The reason behind lies on the charges. The stronger the charge, the greater the tendency of pulling electrons towards the central metal atom, and the weaker the bond holding the hydrogen atom, hence can easily be removed. This one can be easily removed than that one. That is explains the reason why it's difficult to remove electrons from the complex with positive charge. And we go to question 6. A. Complex compounds can sometimes exhibit isomerism. The compound, this one, is isomeric to this one. This complex is isomeric to this one. The difference between them is just In this complex, this one is out, but this one is in. 1. Give you pack name for each isomer. We're supposed to name this one and to name that one. We're supposed to name in naming complexes, we have to observe the rules. For example, in this case, there are 2 types of ligands. We are having amine and bromo. If there are more than 1 type of ligands, by UPAC rule, you name the negative ligands first, followed by the neutral. So in this particular case, it is bromo, this one. If I name this one as X and this one as Y, then the complex X will be named as bromo. 5 of them, so it is penta, amine, cobalt, we start the position state of cobalt in this complex. Since it is balanced by a sulfate, it means that the net charge here is 2. For this one to be 2, this one must be 3, so that 3 of this one minus 1, you get positive 2. So it is cobalt 2, sulfate. Leave space, say sulfate. This will be the name for that. The name for the other complex, this is the negative ligand, so we name it first. This is called sulfato. Pentamine. Because there are 5 of them. Sulfato, pentamine, cobalt. Since this one is balanced by an anion with a net of minus 1, it means here it is minus, it is positive 1. If it is positive 1, and this one is having minus 2, this one is 0, this must possess positive 3. Bromine. Let me repeat it. Since this complex is balanced by 1 bromine, 1 anion, which is having minus 1, it means the charge of this complex is positive 1. For this one to be positive 1, this one must be positive 3, so that when you add the minus 2 and the 0, you get positive 1. So it is 3. So it is sulfato, pentamine, cobalt 3, bromine. Two. What ions will each isomer yield in solution? It's X. This isomer, if you put it in solution, the ions it will yield will be this one, and that one. But this one, in solution, it will yield and that's all. Three. What is the oxidation state and the potential number of cobalt in each complex compound? What is the oxidation state and the potential and the coordination number of cobalt in each complex? The oxidation state of cobalt in this complex is positive 2. If X oxidation state of cobalt is positive 2, in what the oxidation state of cobalt is I'm sorry, it is 3. It is 3. Because if it is having 3, minus 1, make it positive 2. And in 1, it is also 3. Because 3 minus 2 equals 1. It is positive 3. The base set of this one is positive 3. So that 3 plus 0 minus 1 equals 2. 3